Okay, so for today, let's try to implement an ini file type parser. So, um, like this will be like the format that we are gonna support with sections, variables and the values and stuff. So we're gonna do this in C because, yeah, why not? We might need it to configure, like for example, if we manage to fix the particle simulation, we can try to configure it with ini files so that we can have multiple uh, types of water or whatever, like, yeah, it's just a cool thing to have, I think. Cool little library, so we can have it like a .h library or something. So yeah, let's see. So I have here the main file. Let's start with the usual hello world. So yeah, and why not, let's just grab this thing and have like an example .ini file. So yeah, let's say that we have the example like this. So the first step that we need to take is basically to tokenize this file, right? And we'll implement that by going character by character, and depending on what type of character we encounter, we are going to create a token. So for example, if we encounter this square bracket, we're going to have a left bracket. Then after that, we're going to encounter these letters, right? So if it's a letter, then we need to read the entire word somehow. That's going to be interesting to figure out. That's going to be a separate token, like a string token, or maybe yeah, like an identifier token, right? And then here we're gonna have another square bracket, but closing square bracket. Then on these ini files, I see that new lines count as separators. So in C, for example, we have semicolons to separate the lines, but in ini files, I see we have new lines. It's the same as Python, right? You basically need some separator between lines to work. So yeah, then we have the separator, which we can skip. But then again, we have an identifier. Then we have some white spaces. I guess you can have as many as you want, or maybe even none. Then we have this equal sign, which again we parse. And then we have some other tokens. So maybe this is gonna be like a token, then a space. But like the idea here is that we might want to just parse everything as one thing, right? So yeah, somehow we need to see that well, maybe after we find the equal sign, we kind of know that next should be the value. So that's something. And we read until the end of line. I'm not sure about the white spaces here. Like, do we trim them? Like usually in Toml you would have to, yeah. I mean, why not? We can try to say that if we found an equal, then we read everything until the end of new line, right? And that's the value token. So basically, yeah, that's the idea. For comments, we're gonna skip them, and yeah, let's see. So as I said, we are gonna need to read the files, right? So I mean, we already did something like this in the brainfuck compiler. So yeah, basically let's see. So we have read input program, right? Like this was the okay, and let's have this stuff, and of course we need the string.h and stdlib. Okay, so basically this thing reads either from standard input or from the file if you provide a file. If you don't have a file, then yeah, basically it will just use stdin when it does the where it is fgets, right? So yeah, I mean basically that's the function. Um, so let's see, let's actually have rc and let's use the first argument as the program name, or I mean it's gonna be input file, read input file. Let's rename this to input, and I think that's it. No, input file. Okay, so now we have the input file. Let's print f it. So let's see. Perfect. We can actually read it. So that's the first step. Now let's see. So my idea is to have this structure called lexer. I already did something like this before, but it was like for a programming language. But the idea should be similar. So let's have struct lexer. So we are gonna have the pointer to our input. Then see we're gonna have the position of the cursor. So basically, if we were to draw this thing, well, I mean drawing it is a bit stupid, but let's say we have text, right? Wow. Let's say we have text, and lexer would be something that goes character by character with this pointer, and yeah, basically we look only at one character. Like that's the idea. And based on what character we find, for example, if we find equal, let's say, in our case for ini files, we might go on a branch that reads everything after it and puts it into a value token. Okay, so like into an assigned token. So I mean, yeah, I guess this kind of structure would work. We need the input string, the position of the cursor, usually you'd say instead of the current character you would have unsigned int read position or something like this. So the next thing is to have the structure for tokens, right? Like let's have struct token. Basically, we are gonna need the value of it. So for example, we can have this thing like literal, and we also need the type. So in token type, and sure, we can have illegal in case we have some error. We can have end of file, why not? And the other things are L bracket, R bracket. Then we're gonna have, well, I mean, we could say that this entire thing is is like the section name or something. But I think it's nicer to just keep it. And this would be the section token, right? And then variable and assigned value or something. So yeah, why not? Let's just have let's say section. Then we have key and value, right? Like these are the wait, what? Anyway, and okay, sure, fair enough. Let's call it end. And yeah, you're also gonna have the token type. Okay, the only issue with here having a char pointer is that we would have to copy the strings, but it's enough to have like a reference in the input itself, so we don't really need to copy the strings, right? So it might make sense to have another structure called something like string view, which would be a pointer to the string and its size, right? So for example, if you have this text, let's say the string view pointer would be just a pointer to t and the size 4. So for you know that you can look in the input string and take 4 bytes from t, and you get the literal. So yeah, let's have that struct string view, and we're gonna have the char pointer data and the length. So here instead of a literal, we are gonna use a string view. Okay, so well, I guess, yeah, like maybe, yeah, I mean, no, it's fine, yeah, it's fine. So, let's create some helper functions, right? So, for example, int is letter, we're gonna have the character, and basically we support like lowercase, uppercase, all of these letters. I guess names can only have letters. Not sure if you can have dots and stuff in the keys themselves. I mean, here I see like spaces, but I mean, let's not do that. Let's just keep like the name will be equal to the variable name or something. I mean, it's weird to have spaces in the key. So yeah, let's just have you know uh I mean, yeah, sure, let's do it. So um letters is okay, so characters are basically like bytes, right? Numbers from 0 to 255, and that means we can actually just compare them like this, right? So without the last one, so we can say that like A, for example, see it has a value of 97, right? And Z is 122. So if you have any character in between, then it's a letter. Okay, so the next thing would be is well, is digit would be nice. Like makes sense to also have is digit. And now let's do is valid key name, for example. Is valid key name. Is valid key character. So basically we are gonna allow digits, letters, and underscores in the key names. Well, we are not gonna be able to start with digits, but because again that's weird. Like I can have double standards on white spaces in the names, but be able to start with digits. I mean, I don't even see examples with digits, but like it is like why not? Okay, so the next thing would be is valid section name, or I mean character. But yeah, like for valid, see, like maybe it would make sense to split this into like this token, and then have another token, and then have a dot token to do a better analysis. But mm, the question is, do we really care about that? Because like the purpose of this ini parser is more or less just to be able to do this kind of mapping. Like we don't really care about sections having, for example, this kind of crazy section, right? like this would be identifier or something. Yeah, let's just go with this. Is valid section character, and let's say the same thing. Anyway, sure. We are also going to need is white space. Fair enough. So the next thing is to initialize our lexer. So void lexer init. We are going to say something like this. And yeah, I mean the first thing is to like read one character. So read position should probably, or I mean, no, like the read position is where we are looking, and the position itself will be one larger. So yeah. Okay, then let's also store the character, and basically this is how this should work, right? Something like this. But would be nicer to, let's say we define all the functions. So we also have char lexer read char. Well, this one could be void. I mean, why not? Let's leave it like this, and we are also gonna have next token. Okay, something like this. So here, let's leave this to 0, and yeah, why not? We initialize the character and then we read one character to make it more consistent. So basically, let's think of the lexer big character. So basically, we want to get like the character under the read position. So this would be like the next character, and yeah, let's say obviously if the read position is out of bounds, then we're gonna return 0 because we cannot look ahead. It's like nothing there. And after that we just return the character under the read position. So we're gonna have two positions basically, the position where the lexer is and the look ahead. So we might need the look ahead, let's say well, yeah, we don't really need a look ahead, right? So it's not really needed for this case. So I mean we can even discard it then. But yeah, the idea with the lexer is that if you need look ahead, then this is how you would do it. but I don't think we need look ahead in this case. Well, we could, like for example, when we read this stuff, not really. I'm not sure if we need look ahead. I was thinking to look ahead for new lines, but I don't think it's gonna happen. So in fact, we might just need the next token function. So I don't think we even need these helpers. But let's just keep it. So just maybe to see like the idea of how to do it. So we have the pick character, and now let's say we have the read character. So this one should be similar. We did the same thing here as we did for pick, like for pick, yeah, obviously. So I think what we can do here is to actually say, like, why not just say peak, or am I wrong? So if the read position is larger than the input length, we do a 0, and otherwise we do the input or the character from the read position. So why not just pick, basically? Then we update the position and the read positions. So this is how we read a character, right? And now let's see how we are gonna implement the next token. So first of all, we might want to skip all the, let's say, all the new lines, white spaces, all the comments. So let's have another helper function. It will be void skip white spaces. So we are gonna have, we need to define these first. So we are just gonna, like, while we have a white space, we read the character, we skip it. Then let's say we want to skip void skip line. Maybe it was like a comment, and we want to skip, right? So let's say that we have another helper function is new line. Well, new line is basically just this. But I mean, it makes sense to, it's like a single if, so it doesn't matter. Like, this could be used to skip until the next valid thing, right? So for example, skipping comments. Okay, do we need anything else? So in this function, we need a switch statement over the character. Basically, so let's say that we're gonna switch over the character, and we have a few options. Well, I mean, a switch isn't really ideal in C. So if basically if we have a 0 token or a 0 character, we just return the end of file. Yeah. Oh yeah, I forgot, we need to skip white spaces first, because we might even start with white spaces. Okay, then let's do the comments. So if we have a character equal to I mean, I think hashes are also comments in ini files, so why not? So if we encounter one of these, we just skip the entire line, and then we recursively call to this thing to get the next token, because we didn't got any token when we skip the line. Okay, so now let's get into the more interesting stuff. For example, what if we find an opening bracket? Right, so first things first, we need to get over this character, move on to the next one. So we are gonna read Parser read char. Okay, then we need to build this literal. So let's create a string view for the literal, and I guess the data that we are gonna have in this string view is, well, the pointer to, where did it go? Okay, here we're gonna need the pointer to the first character of the string, so that's basically data equals L input. This is the start of the entire input, so we need to add the position, and the position is just where our cursor is right now, and it's on the O because we read another character. And for now the length is 0. We don't have any characters in this literal. So what we need to do now is to keep reading characters while we don't find, or I mean while the current character is different than closing bracket. So we have to do while loop, L character is not equal to this thing, or the other case would be that we reach I guess end of file, which would be bad, but yeah, it is like if we find the 0, it means that there was an error. So now the current character is basically on top of this one. Right, so yeah, we have to just skip it. Okay, we skip it, and we need to return this token. Okay, I'm curious if returning a token like this will work, right? Because usually you have to return a pointer, but we have to see. Okay, let's see. Let's have here return illegal. So let's try and get the first token and see what we get from this input file. So let's create a Lexer. Let's initialize it. Okay. And let's have a token equal to the next token. So let's printf the token type. We need to compile the thing, and we get a token type 2, which is a section. So that's pretty nice. Now if we try to show the data, this won't work because we point to this this O right here, but the issue is that the null terminator, like the 0, is at the end of the file, and printf doesn't print our string buffer like we want to. It prints it, with until the end of the string, until the 0. So yeah, that's the only issue, but that's good. So the next character that we can find is a simple letter. Well, let's say that all the keys have to start with a letter. They cannot start with a number or with is letter or with an underscore. Should we also do underscores? Why not? But not with a number. So again, as before, we need to create the literal. This time we no longer skip the first character because the first character is our letter, so we don't have to skip it, which is nice. But well, now we can make use of not really, because we are gonna read while is valid key character. While we find the valid key character, we just read the next character, right? And if we find an invalid key character, we stop, and we don't have to read once more because we are gonna be on the invalid character, or I mean, not really invalid, but the character that it's not a key. So we can just return it, pretty much. So that's another character, And the last thing that we can find is if the character is an equal sign. So if we find an equal sign, and I think this might be interesting. How are we gonna handle it? Well, I was thinking to read the white spaces because I see some white spaces, and then we just skip the entire line and take the thing that we skipped as the value. Like that's my idea. What's a bit strange is, like, if we have quotes, do we interpret them as escape? I mean, I guess so. Like, we are gonna take these values as literal values, like these are the values. If they have quotes, then they are escaped and stuff. So pretty much that is my idea. So we skip the white spaces. Now we create the literal, right? We create the literal. Then we skip the line. So I already forgot that, but skip line reads until the character is a new line. So if we are on top of a new line, we stop. So we're gonna be on the new line. Okay. So then we just have to, we have to save the position. So unsigned int start is the position, and now we just have to say no, the length is the new position minus the starting position, and I think that will take into account the +1 that we would need to add just because we skipped the last character and we are on the new line. So yeah, I think that's good, and we have to return the token. Perfect. I think this is good. Okay, so let's try and see what happens if we say something like while token is not end, we print the token and then we do next. Oh my god, that's how you print it. I never knew that. Okay, I mean, Copilot can be useful sometimes because I didn't know how to show just n bytes from a string, and that was the problem. So yeah, see, we get token 2, which is a section, then we have token 3, which is a key. Oh, we need to skip this stuff. So oh yeah, I forgot. If it's an equal sign, we need to lexer read character, then we need to skip the white spaces. So yeah, now we have the section owner, the key name, the value John Doe, then organization and this thing, another section, key value, key value, key value. So yeah, pretty much it's tokenized. So the only thing we need to do now is to create, let's say, the data structure that will hold the data. So what I'm thinking is we're gonna have a list, and it would be more complicated, but let's say we have the section name and then a list of key value pairs. So let's try to do that. So struct key value is gonna be to string views like this. And then let's say we're gonna have a struct section, which is gonna be the name of that section and all the keys and values. And then let's have another structure for the ini file, which is just a list of sections. But what I think I'd like to have here is items, count, and unsigned capacity. So this will be like if you know, you know. That's what I'm gonna say with our DA append thing. Oh, it's already here. That's interesting. Although I want to use the one from ds.h. I'm not really gonna import all of this thing, but I'm just gonna copy paste this stuff. Yeah, like just adding this would mean copy pasting more stuff, so it would be annoying. Then yeah, sure, why not? Let's just oh no, I lost it. No. Oh, this is the main file. So it's this stuff. Let's have it on top. So yeah, basically this is just appending one item to an array list. Pretty much it's just an array list from Java. So now that we have all the tokens, let's see how we can actually put them into an ini file. So we need to do the parsing. Okay. We need to do the actual parsing. Yeah, we can try to follow the same either the same type of structure, and just ignore the errors for now. So yeah, because we are just gonna have, let's say, a parser, and it just needs to build the ini file. So it will be something like ini file parse, and we are gonna pass in the pointer to the ini structure and the string input. So let's also have a token array just for the parser. So it will be struct token array, and yeah, what I'm thinking is pretty much just this thing. So here we pass in the input, the lexer. We are gonna need struct token array tokens. Let's initialize it to 0 basically, right? Yeah. And instead of printing, we just have to append. And here at the end, I would still append the last token just in case. So now instead of doing this stuff, let's create the ini file and let's parse it. So for now, let's make sure that the thing still works pretty much. Yeah, still works. Okay. So now, if because it's easier to just go with a for loop. Like if we encounter a section, then we need to go ahead and build the section. So how are we gonna do this? Is basically, let's have another parse function. So this one will actually take the ini and the struct token array pointer to tokens. Okay, it will take the pointer to the tokens, and I think it should also maybe take in the cursor position. So we actually could have a parser structure. Let's call this one parse. Or I mean something like ini parse. Alright, so we could have a struct parser. So it will be the list of tokens and the current position. So here instead of this thing, let's have struct parser pointer p. This is how this is gonna work. And here we need to build the parser. It will be all the tokens and the position is 0. And then we need to call to this thing, to the parse. So we need to take the current token, struct token is the current token, and now we need to do an let's say an if statement. So if we have a section, the token type is section, I was thinking to create a new section, right? Create a new section. Then we should increase the position. Well, say like it makes sense to also have that read what is what's called like read character, but this would be read token. Well, it doesn't matter. So we create a new section basically, and yeah, what I was thinking is that the ini file should also have the default section, right? Let's say struct section, it should be the root section, and it only has one. In case, yeah, basically in case it has like any stuff in here. So if we find the section, well, it must be easier if the token type is equal to key. If we find the key, and then we have obviously else. So if oh, here we can use a switch. Why not? Switch token type. Case key. If we find the key, then we need to build the key value structure with the literal and we should do one more step actually, and take the value. So it should be, oh, this is so bad. Yeah, let's have a structure token parser edit token, so it will just give us the next token and increase the position. And I think here we should do read token. Okay, Next thing would be, well, here it would make sense to check if the position is out of bounds. I guess, I don't know, to be honest. Struct token v. Let's say we just ignore all the errors for now, and we just take the literal. We just assume that everything works because why not? And then we do da append, and here we need to pass in the root, and we put kv, the key value. Or I mean, let's just do key value, and then we initialize it like this. Although we need, I think, to use parentheses around it. Yeah, just like that. Maybe that works. Although I remember from previous time that the append didn't really work like this. Because it tried to actually copy it. Anyway, we'll see if it doesn't work. So case, we find the section. We actually, let's say we need to create a new section. And here we need to append it. But we will also need to do read it. But first let's see if this will work. So if we find illegal and or value, that's not correct. So as I said, we just assume that everything works. Cool. And the last thing, like this. And this should do the parsing for the ini file. So now let's see. Section. Well, I mean, whatever. And the root ones, so for, I think all of them should be inside of root. So we get section owner, which is good. But then don't we get a key just to come here? No. Why not? What else do we get? Printf. Wait. Yeah, I forgot to do something. Which was actually the for loop. So yeah. while token type is not end, we have to actually do this thing, and at the end we read the next token. And yeah, basically then if we go too far we return end, and otherwise we return the next one. So this is how, I forgot to loop over it. So we get the two sections, and then all of these are put into root because it doesn't know how to put them into their own section. So to put them into the correct section, we need another function that will actually parse the section. So let's put this one here and say section parse, and this should be the section S. So here we need to section parse S, and the reason why we need to also parse send the parser here is to increase its position and update it, like leave it on the next section basically. So we need to read the first, we need to read the first token. Yeah, we need to read the first token. So while we are not at the end and we are not encountering another section, right? If we find a key, we read its value and we append it into the section, and then we get the next one. So yeah, I mean, we are ignoring all the errors, but what we should do instead is maybe just crash the program on error. So but first let's see if this works. Let's see if this one works. So okay, then we might actually, like here, we might actually want to have a pick function. Let's see. So start token parser pick token. So yeah, pretty much this one just shows you the, well, I would like to see the next one though, not the current one. So it's more like look ahead. Like if the current token is end, it's over, and if the current token is section, is also. Oh yeah, so basically here we read, so now we are on the next token. So first thing here is to pick. Oh, peep is to pick. Or what? Let me see. So yeah, we have to pick. So here we edit the token, and basically that means, let me see how I did it here. Mm. Well, yeah, maybe it's not a good idea to advance the parser, although I think it's fine. I don't see why not. Okay, let's say it maybe works a bit differently. So peak shows us, well, then why not actually have here unsigned int edit pos and struct token pointer current token, or let's call it toc just to be fancy. So how does peak work? Right, so it should work similarly to peak, like to this one. So if the read pos is larger or equal to count, we return the end token. Well, what? I mean, this is just picking, so. And here we just have to show the this token. Then for reading, basically read the char. Read char is just, I mean, it's similar to this thing, but it's not really that, because we need pointers. So p toc is gonna be, well, yeah, we need an if statement. So if the read position is too large, okay, and now this makes sense to have it as a void. We need to say something like p toc is gonna be equal to p tokens. Well, I mean, this is so annoying. Well, clearly it's just larger, so it should be tokens count minus 1. Wow. And otherwise we just set it like this. Then we need to set the position to read position and increase the read position. And here we don't return anything. So, for example, when we do the file parse, we need to first of all just pick, right? I don't think we want to, well, for me it makes sense to do read. Like I would say something like parser read token. This will advance the parser. then let's say struct token pointer token is this thing, and if while this is not equal to end, we can do a switch on the type. Although yeah, it could also be like this because it's never gonna be null, so it's fine, I think. Well, it could be null, but when we initialize it, we need to read one token first. So now we are on the first token. We take a look at it. If it's while it's not equal to end, we can switch on the type. So the next thing would be to I don't know, read one more token. Read one more token. So this would be the value token. So we take another one and we just append this. Now if the current token that we read is a section, then we need to parse the entire section, append it, do whatever, and here we need to read. Do we need to read, or do we just need to update? I think we need to read here just to skip that, and we don't need to read again, we just need to update the token. So like we read once to get on top of the value, and then we read again to skip the value and go on the next thing. Then if we find the section, that's good. Here we just need to get the first token. If this token is the end or another section, we have to stop. But wait a second, because that token is in fact a section, we have to read once to skip the section, right? We have to read once, yeah. So we read once here, then this would be a new token, like most certainly it would be a key. We take the key, then here we need to do another read similar to this thing. We need to do another read to get the value, and I think we need to do yet another read to skip that, and here we just do something like this. Prepare for a segmentation fault. It worked. Instead of a segmentation fault, we actually got the parsed ini file. Isn't that amazing? I was expecting a segmentation fault. Anyway, yeah, we don't do any error handling, but that would come naturally with more examples. So for example, my god, there are so many structures and things. So basically, this thing cannot really show any errors. Neither can this thing, doesn't make sense. Or the peak. Even next cannot really show errors. I mean, we show errors by using the illegal token. right? And here we could even do struct string view and pretty much show the character that caused the issue. We can even do that, right? If we have a semicolon, we checked. Let's put this one first because it's if we find end of file, we return end, comments, the section, if we find a letter, if we find equal, and otherwise we just say illegal token. And then we have these key values, the section, inifile, the array of tokens for the parser, right? Pretty much this thing cannot really show any errors, neither can this one. And now in the parsing, so like here we assume that it's a value, so that's not really ideal. Let's say, let's just call it like that. Probably here we need to check that v's value. But I was just thinking, usually a parser doesn't fail just on the first issue. It gives you more like all the problems. But I mean, to be honest, in this case you cannot really recover from this error. Like if you don't have a value after the key, how do you recover from it, you know? You just do what, basically? Like if you find a section, then unexpected section found, basically, you know? So here let's say if we type article value, let's see, because yeah, in ds.h actually I had a really cool function. It's ds panic. It's the ds panic one. Yeah, GG. Let's put it here. And what else? I also had this one, and this is just exit, which is from stdlib. So wait, yeah. Well, I mean, let's use like this. Yeah. So oh, I forgot what it was. So here, let's say ds panic. Oh, I also used colors. Well, yeah. Basically, this works now. So if we have a section after a key, it's gonna fail on this one. So let's try to do that example. Let's say we don't have equal here, we just have that. Let's recompile the thing, and it's gonna say error. Expected value got database. Yeah, well, the errors could be more descriptive. But pretty much, yeah, if it's not a value, then we can panic. Right? So the next thing here is, again, here we assume that it's a value. So let's take this thing and let's put it there. Then for section, not really important. And actually in the default, we can also have something like this. Okay, it's fine for now. Let's go to the enum for token type, and let's have something const char pointer, basically. Yeah. So now let's go back to our panics, and I guess the improved error would be expected yeah, like expected value got token type and then percentage s with value. So v dot type, oh, it's a const char pointer type. So now if we go back to example and delete that, I forgot about whatever that one, not important for now. Expected value got type section with value database. Let's not use let's maybe put it into parentheses, like section. Okay, so we could even have stuff like SD here, and if we run again, we get got token type key. If we have just an equal, ooh, yeah. Then skip white space should skip just the equals, like the spaces. Okay, so let's go back to, oh my god, let's go back to main, and here when we encounter an equal, we don't really want to skip white spaces, like all of the white spaces. Now I want to say skip white space. Avoid skip spaces. Int is a space. I mean, I would say it's also the tabs. I think. So here I would rather say skip spaces. And now it's empty. Perfect. Okay, anyway, let's continue with the panics. So this thing is fine now, I think. Okay, let's have something there. Now, here this should be the same thing. So if we this is interesting. Let's have a parse key value or something. Because this is repeated in some way. Void key value parse, and let's see. So it's gonna be this thing. We need to pass here struct key value and the parser. Okay. And before we do anything, we need to take that thing and something like this. I think this is a bit better. So struct key value kv and we parse it. So pretty much this is actually the better way of doing this, I think, because it's just we have less duplicated code that can fail. So we just have a single panic now instead of two. I mean, it's the same thing, but we just have to modify in one place only. So yeah, here, again, we could have a switch statement. It would be better to use a switch. Switch case key. We do that. And if it's anything else, it's gonna be bad news. So it's obvious. It can only be value. So it should have something similar. Expected key, but got token type, and type is what? The type is the type of the token, I think. And we can show something like this. So now if we go into the example and we can have something like equals, it will say expected key but got value. Okay, that's nice. And this one can also go here, but in this case it's gonna be more like expected key or section, and then got this whatever. So if we go here and say something like equals whatever, we compile it, expected key or section but got type value. Okay, and if we have something like sum key equals sum, that it lets you do it. I think that's good. So yeah, I think this is pretty much what we wanted. Mainly the only thing that we need is this ini parse right here, and that means we need a structure ini file, section, and key value. We need these three structures to be exposed. Maybe we should have like a function here that takes in this, maybe a section name and maybe also the value. So something like, oh, it should be more simple than that. So it should be ini get value, should be the structure, should be like a const char pointer, it should be section, and const char pointer, it should be a key. I mean, we can have ini get section and section get value, but let's make it simpler. So if if strcmp section root equals 0, then we just have to iterate through the root ones. Okay, let's do char pointer, right? It's more like the string view, but I think we want to not be able to change, like have it immutable, the ini structure, I think. So let's keep it like this. So then we have a for loop, right? Like this. And here we might want to alloc and then return the value. So why does it complain here? So like trying to use that instead of, anyway, let's say struct string view is the k, and here we want to do it like this. I mean, it's sometimes like Copilot, it's like it's stupid or something, cannot figure out simple stuff. So yeah, that's I mean, see, like, no, struct section. Anyway, because I was thinking, well, if it's gonna be a copy paste for the other one, so might make sense to have struct section get section, something like this. So yeah, and if strcmp name root, then we return just root. So let's first of all struct section, we get the section, and then instead of using ini root, let's use s. Let's use s. So here it's let's see if we have root nowhere else. I mean, we don't even need this then. We could just do something like this, but then it makes sense to have it as a pointer. Here its not name is section. Why not just use the address? Here is again section, and yeah, now we have to use but now we can check if it's null. So if the s is null, then we can do anything. And then again here we return null because we didn't find anything. So let's rerun everything. See, let's say we want to get the ports from the database, right? So port equals database port. The port is port. See, and now we can easily just access the section and the key. So basically this is gonna be the usage. You are gonna call to ini parse. You are gonna get the structure back with the parsed contents, and then you are gonna specify the section, for example, like root. This should segmentation fault because oh, interesting. It just showed null. Perfect. And yeah, like you say the section, the key name, and you get back the value. So if we look at example.ini, we have this data inside of it, and the parser parses everything into a list of sections. We don't really use like trees and stuff, we just have a dynamic array of sections, and each section has key values, just simple key values. And yeah, let me recompile the thing, and yeah, basically you can access the section and the key after you parse a file. So yeah, pretty much we might use this, especially for the simulation thing. I mean, I'm gonna use it. I'll have to make it into a header only library though. I think that's the best way to handle something like this. Oh, it's pretty huge, but I mean, it it works. I think it was a good learning experience to see how to tokenize and parse something as simple as ini files. I mean, they're pretty simple, so you can imagine that something like JSON or YAML would be harder. But yeah, we got the right results, and that's it. See you next time.